Okay, in this presentation we're going to look at how to compute the confidence interval for population standard deviations or otherwise population variances, and then you can use standard results, the square root, to find the equivalent for a population standard deviation. Essentially what we're dealing with here is sampling distributions and stuff like that and sample variances. Do you know what? Let's just read the question and get stuck into it there. So a random sample of 30 observations is drawn from a normal distribution, okay, just make a note of that, with unknown variance. That's sigma squared. We don't know what it is, okay, unknown, okay. Write down an expression for the distribution of S, the population standard deviation, and the sample standard deviation of S equals 7.5, okay. Calculate a 95% confidence interval for the population standard deviation, okay, which would be sigma, okay. Or really what we're going to do is work in terms of sigma squared and then go to sigma, okay. So we'll just sort of stick with the easiest approach to do it, and then just amend our answers, like get the square root of them to get the actual answer we're looking for now. So just actually what we're going to be using here is the chi-squared distribution here, okay. So what I have here is some code for quantiles. Now this is using a programming language called R, okay. Also, if you're trying to Google it, you might sort of say R stats, just to make the internet search a little bit easier. And what we're dealing here is the chi-squared distribution, okay. And if you're not familiar with that, chi-square, okay. And what we're looking for here is quantiles, okay. Now, so we have percentiles. This is the 2.5% percentile and the 97.5% percentile. So it's 95% is between those two parts of the distribution, okay? And also, just as a quick remark, the degrees of freedom here is n minus 1, which is 29, okay? Now, so the answers we're going to get, or the numbers we're going to be using shortly, are 16.04 and 45.72. Now, I'm using R for this one, partly because chi-squared statistical tables are very clunky, but if you are trying to get the hang of statistical tables and you need to just practice how to use them, I suggest using R to help you make sure you find the right answers, if you get me. So just a way of sort of just double checking your work, or making sure, cross-validating your work with if you have to use statistical tables for an exam. Okay, so a little bit of knowledge about R can help you improve your use of statistical tables, because they can be very clunky in an exam situation. Now, the first thing we're asked to do here is actually just create this expression here, the distribution of the population variance, okay, or the sample variance, and with regard to the population variance. Essentially, this is all that's really needed here, okay. Just actually sort of state that S squared is the sample variance, sigma squared is the population variance, n minus 1 just degrees of freedom, and this is chi squared. Again, just as a remark, something I should have put in is that the degrees of freedom there for chi squared random variable would be n minus 1. So that's not x, that's chi squared there again, chi. It looks like a big X, but it's not an X. Not exactly X, okay? So that's really just an expression of what we need to get going. And I think really that's what part A asks of us. Write down an expression for the distribution of S, the population standard deviation, okay? So you can just, that's sort of fine, really. Actually, really, the question should be about the population variance rather than standard deviation. But anyway, there we go. This is what you need to know to continue. Now, so the key part here is what we're going to do here, and this is the real part of this question really, is this part here, the 95% confidence interval for the sample variance. Now, I'm starting off with the sample variance, so what we'll do when we get our answer is just the square root of it for the sample standard deviation. Now, so it's 95% confidence interval. That's sort of more sort of a reflex there, okay? But actually, what I should have said here down below is that this chi-squared n minus 2. So we're actually going to use the larger of the two values down here, okay? So it's a little bit intuitive, counterintuitive that use the large one at the lower end and the smaller of the two values there for the upper limit. Okay, so if you bear with me a second, we're going to use this for the upper limit of the confidence interval, and L, the lower limit. Okay, little bit of a sort of a trick, not a trick, a sort of banana skin with these sort of questions, that they sort of go in the opposite place to what you would sort of expect. Okay, now that's to do with the derivation of this formula. I'm not doing the derivation of this formula. It would make sense there when you're sort of rearranging a formula like that the things switch around. Okay, so you can just trust me in that. Now, so that's essentially what we have there, is everything we need. Okay, so I've taken care of this part already. Okay, so you have 16 and 16.04 and or 05, let's say, and 45.722. So we're going to use these in our answer. In fact, really, we actually have everything we need now. Okay, so there we go. Sorry, you can disregard that. That's the wrong way around. Actually, that's the other way around. But so you can just disregard that. I actually spotted that mistake myself. So that is the n minus 1 over chi squared, and this should be the 97.5 and the 2.5. Essentially what we do there is just put in our numbers there. So 29 times, that's n minus 1 by the way, is 29. S squared is 7.5 to be squared, and chi squared there for the 97.5 percentile is 45.72. Likewise over here, 29 times 7.5 squared over 16.05. Okay, and when we work that out, we get 35.68 essentially, or 679, and 101.64, 101.64. Okay, and the answer really is actually about the 95% confidence interval for sample standard deviation. Okay, so essentially you get the square root of those. We get 5.95 to 10.08. Now really, just to sort of put in a sentence just to explain your answer fully, don't forget this part here. This is what you're actually asked here. This is the answer that you're seeking here, not this. Okay, so this is not the finish line here. This is the finish line. Just put in a little sentence there to finish it off, and then you're done. Okay, so we'll leave it there.